All right, if you're a technical leader working in a GxP regulated environment, you know the dilemma all too well. The push to adopt AI is just unavoidable, but the risks, well, they're completely non negotiable. So today, we're going to cut right through the hype of all those simple AI tools and talk about what it actually takes to build auditable, high impact AI systems that can really withstand scrutiny.
Okay, let's dive right in. This probably looks pretty familiar, right? Most enterprise AI projects in regulated spaces are stuck way down here at the bottom. We're talking chatbots, knowledge helpers, summarization tools. The low-risk stuff that has pretty limited business impact. The goal, of course, is way up at the top, regulated automation and genuinely high-impact AI. But man, getting there feels almost impossible. The real question is, why?
Well, the reason these initiatives stall isn't what you might think. It's not a failure of the models themselves, and believe it or not, it's not even the fault of the regulations. The problem is what you could call an architectural ceiling, one that most teams hit without ever even realizing it. The very design of their systems is what prevents them from moving up. Let this one really sink in for a minute. If your system isn't auditable, the fix isn't better prompt engineering or grabbing a different model. The problem is much, much more fundamental. Your architecture is failing, and no amount of tuning around the edges is ever going to fix a flawed foundation. And you know what? These failures, they follow really predictable patterns. You've got uncontrolled intake, where basically anything can be fed into the model. There's silent promotion, where a model's guess just instantly becomes a recorded fact. Automation that you can't undo. Memory that just piles up without any policy. And then there's mixed authority, which just blurs the lines between what's a suggestion and what's an action. These are all design choices, and in a GxP world, they are absolute gateways to systemic risk. So this brings us to a really important way to reframe how we should be thinking about regulation. It is so easy to see GxP as just a blocker, right? As something that just gets in the way of innovation. But a much better way to look at it is as a forcing function, a beneficial constraint that basically stress tests your design and exposes these underlying weaknesses before they can cause any real harm. And this just brilliantly illustrates the point. If your AI system can't withstand regulatory scrutiny, the regulations didn't block your progress. They revealed that your architecture was never strong enough to begin with. In a way, they're doing you a favor by exposing flaws that would have eventually led to failure anyway. I mean, think about your daily reality. Traceability, auditability, explainability, change control, and of course, ultimate human accountability. These aren't suggestions. They are hard, non-negotiable requirements. And they are not solvable with a few clever prompts. They are system-level properties that have to be answered with deliberate, thought-out architectural decisions. So how do we build systems that can actually provide these answers? It all starts with one foundational principle that has to guide every single design decision you make. And it's this: you must establish control before you allow any reasoning to happen. This slide really visualizes the core category error we see all the time. Yeah, we access LLMs through APIs, but they aren't deterministic. Not at all. They're probabilistic pattern engines, where the same input can give you different outputs. So if you don't govern the input with a formal contract, you have absolutely zero hope of governing the output. And this is the consequence of getting that wrong. Once a probabilistic engine runs on some uncontrolled input, the risk has already spread through your system. Trying to add guardrails to the output at that point, it's just too late. The potential for error is already baked into the system state. So let's pivot to the solution. Building for control requires a very specific architectural model. It's called the Operational AI Systems Program Builder, or OASPB for short, and it gives us a concrete blueprint for creating governable AI systems. Okay, at first glance, I know this looks complex, but the core idea is actually pretty simple. The OSLBP isn't a single application. Think of it as a meta-level control plane. It's the system that governs how different AI subsystems are built and allowed to interact. Just notice the clear separation of concerns here, from intake all the way on the left to the governed outcomes on the right. This very structure is what makes auditability possible in the first place. Now, the most critical component is right there at the beginning, the universal intake layer. This is the practical application of our control before reasoning principle. The UIL acts as a policy-governed gateway. It classifies all the incoming data, it gates it, and it creates an auditable intake artifact before an LLM ever even sees it. This is what prevents that primary failure mode of uncontrolled intake.
The next critical separation this architecture enforces is between generation and promotion. Generation? Well, that's what the LLM does. It produces probabilistic possibilities, it suggests potential answers. Promotion is a totally separate, deliberate, and governed act of taking one of those possibilities and elevating it to the status of a trusted, auditable artifact or an actual action. And let's be perfectly clear about this. Silently promoting a probabilistic output, just letting a model's guess become a permanent record without any oversight, is completely and totally unacceptable in a GxP context. Every single promotion must be an explicit, logged, and justifiable event. This separation is absolutely non-negotiable for auditability. And this is all made possible by a core principle of the architecture: append-only artifacts. Nothing is ever silently changed or overwritten. Every intake, every generation, every promotion creates a new immutable record. This ensures that a complete, traceable history is preserved by design, which makes the system both auditable and recoverable. Now, you might be thinking, this all sounds like a lot of discipline, like it might actually slow you down. But the strategic outcome is the exact opposite. This isn't about moving slower, it's about building for correctness, which is the only way you can achieve sustainable velocity at scale. This model shows exactly where the value is created. The work doesn't just disappear, but the leverage, it moves upstream. While the implementer's role is obviously vital, the highest leverage shifts to the architect who designs the constraints and to the system owner who is ultimately accountable for the outcomes and the risk. So I'll leave you with this question to think about for your own systems. Is your architecture designed for the illusion of short-term velocity, or is it designed for correctness under the real-world load and scrutiny of a regulated environment? Because let's be honest, speed without recoverability isn't velocity. It's just accumulating technical and regulatory debt at a really alarming rate. And that brings us to the key takeaway from this whole explainer. Moving beyond these trivial AI use cases in GxP environments, it's just not a matter of better prompts or fancier tooling. It is achieved through deliberate architecture, deep systems literacy, and a real commitment to governance by design. That, right there, is how we build AI systems that are truly worthy of our trust.